Hello everyone, welcome back to ECE100 class 18. Today we're going to talk about inductors. So last class we talked about capacitors. Capacitors is a energy storage device that stores energy into electric field. If you remember last class we have two plates. So energy, the voltage you supply, all the charges comes across the two plates. How much charge you can store across these two plates per unit volts across these two plate is called capacitance. So capacitor stores energy across plates, which is electric field. An inductor is also an energy storage device that stores energy into the magnetic field. So what it means? So when you, if you close the switch over here, current go through this, and as soon as current go through this uh, coil over here will have magnetic field around it like this. So magnetic will build up around this like that. So this magnetic field over here will store energy. So the more magnetic field will have more energy. One thing is that this magnetic field, to build the magnetic field, you need some time, and also to reduce the magnetic fields, you need some time. So energy will store here. It's very simple idea here, but it's a little bit more physics behind it. We're not going to talk about the physics in this class, but physics 260, we'll talk about more how it works in electricity and magnetism. So we're going to leave it here that idea is that inductor stores energy in the magnetic field. So this is what it is. If a current carrying conductor carry current, a magnetic field develops around it. So magnetic fields like your magnet, electromagnet, or permanent magnets. So example is magnet. You see over here that is magnet. It could be a permanent magnet, could be electromagnet, and a compass. All right, and also other things we see everyday use, but we basically don't know how it works. Like transformers, it also works because of magnetic field. All right, and so on. Those are the example of magnetic fields. In physics, we're going to learn more about this, but I'm going to give you a simple idea here. The more current you supply to the wire, you have more stronger magnetic field. So magnetic field and current, they're directly proportional to each other. So the magnetic field is created because of the current, so that energy will store in the magnetic field. When as I say, it takes time to store energy in the magnetic field. Also, it takes time to release the energy from the magnetic field. It's not instantaneous. Again, we're going to learn them in physics 260. Here's the idea that your current create a magnetic field when current goes through the wire, and that magnetic field will store energy. So it takes time to store it. It takes time to release it too. So, and how does it work? When you have current carrying conductor has a magnetic field, it's also have a voltage called induced voltage across the conductor. That induced voltage is relies on this equation over here. But if you look carefully here, L is the inductance of the coil. So L is the inductance of the coil, but it depends on the change in current. If you look carefully here, it depends. So you only get voltage across it. If you only get voltage across it over here, let's say VL, when you have changing current, that means if you have a DC current, you would not see any voltage across it. So DC current would not give you any voltage across it. For DC current, VL is 0 because there's no change in DC current. So we need a changing current to produce or induce voltage across the coil. So that is changing, is increasing over here, and decreasing over here. The increase and decrease will give you a voltage across the coil. There's a video here. We're going to watch them in the class. This, or you can watch it. That video will give you more insight to inductor, how inductor works. There are different form and shapes of inductors. You might wonder what is this thing over here, or inside this, what's the coil here. So in this, inductor is made out of by this coil right here, but inside the coil there's a iron core in there, which call it ferromagnetic iron. This iron core is basically strengthened the magnetic field for the coil. So that is, again, you'll know them in the physics 260. That magnetic field would be multiplied or intensified by the iron core in between the coil. Inductor has a symbol, this electrical symbol, either this one or this one here. In the circuit, we use this symbol for inductor. There's no polarity for the inductor. And as you remember from the last class, capacitive impedance XC, we have it, XC is 1 over j omega L. And inductor stores energy is also frequency dependent. And there's a unit for inductor is henry. Normally we see millihenry and microhenry in our classroom. So L is the standard symbol for the inductor. It's not symbol, a letter for the inductor. So let's how it works. Let's see here. So XL, inductive impedance. Let's write it down here. Is j omega L. Again, omega is 2 pi f. So L, not C, L. So this F is frequency. Again, you can see that inductive impedance also is frequency dependent. So when frequency is 0 for DC, XL also 0. So that means for DC source, there is no impedance. That means is short circuit. So there is no impedance for DC source. And for high frequency, if F goes to infinity, like very high, then XL also goes to infinity, right? So that for high frequency is kind of open circuit or very high impedance, right? So this basically opposite is basically opposite of capacitor. Capacitor for DC source, capacitor is open circuit. For high frequency, capacitor is short circuit. And here for DC source, your inductor is short circuit, and for high frequency, inductor is open circuit. So it's the opposite of capacitor. Again, capacitor stores energy into the electric field. Inductor stores energy into the magnetic field, right? So this is the fundamental of inductor. In the lab, we'll see how energy storing in an inductor works. We'll see that in the lab. And where do we use this inductor? For any power conversion circuit, like DC-DC conversion, AC-DC conversion, we need to use the combination of capacitor inductor in there. And wireless charging, any wireless charging, basically you're inducing voltage with your connection. That is also inductor in there. Filter, you can make frequency filters using inductors. And transformer is the biggest application of inductor, because your primary and secondary coil both are inductors. And there are many sensors out there use inductor, especially metal detecting sensor and proximity sensor are basically inductors. And if you have any hobby to detect metals in beaches like that, that's why you use inductive sensor inside that. And that's all today. I will see you for the next class.